So in both dependent and inconsistent solutions, when we do algebra to solve both variables, both variables get eliminated, right? They completely both go away. So what's different about these two? So let's take look at an example here. So we have, say for example, 2x plus 3y equals 5, and 6x plus 9y equals 15. So this one's in standard form. And so if the equation's in standard form, I mean ax plus by equals c. Usually elimination is the easier way to solve. Although if you want to do substitution, you can. But I'm going to do elimination. And to do elimination, I want to eliminate one of the variables. So I'm going to multiply this top equation by a -3. Okay, and that's going to give my equation, that's going to make my equation. Again, as long as I'm multiplying by both sides of the equation, then the equation stays true. So I'll have -6x minus 9y equals -15, and then I keep my second equation, 6x plus 9y equals 15. And what I see here is now when I go to eliminate, so I'm going to add both these equations together, I get 0x plus 0y equals 0. In other words, 0 equals 0. This is a true statement. And of course, it's true regardless of the value of x or y, right? 0 is always 0. You can't possibly come up with something that would make 0 not equal to 0, right? It's always going to be true. So this is a dependent system. Right? We have that both equations are in fact exactly the same. Okay, so if I were to graph this original line, it would exactly be the same as this other one. So the solution is the set of all ordered pairs x, y that fall in that line, such that 2x plus 3y is equal to 5. Right? It's going to be all those infinitely many ordered pairs. Okay, so we have a true statement, infinitely many true values. Okay, what about if I just change the system just slightly? So what if this were equal to 4 instead of 5? But everything else I'm going to keep the same because I want to really emphasize that how you approach these problems algebraically is going to be the same, right? We'd still multiply by -3 to get -6x minus 9y. But now when I multiply by -3, I'm going to get -12 as a result. And my second equation still stays the same. So the algebra is exactly the same in both cases. And in fact, we even get 0x plus 0y. But now when I add, I get 3 here. So on the left side of the equation, I'm just left with 0 equals 3. And certainly 0 is not equal to 3, right? This is a false statement regardless of the value of x or y, right? Meaning that there's no such possible way that you could ever come up with an ordered pair x, y that would somehow miraculously make 0 equal to 3, right? This has no solution. This is an inconsistent system. Okay, so we could write it as the empty set is the solution. There's no possible x, y values that could make this false statement be true. Okay, so what is the difference between dependent versus inconsistent? Algebraically, everything's going to work out the same. And even on both cases, the variables will be eliminated completely, right? We have no more x's or y's in both cases. The difference is if I have a true statement, it means infinitely many ordered pairs are true. And if I get a false statement, it means no possible ordered pairs are true.